All right, if angle A is equal to 55 degrees, so let's plug that in. What is the measure of angle B? Well, here we see that angle A and B are supplementary angles because they form that straight line. So we know that they add to 180 degrees. So 55 plus angle B is equal to 180. And now it's just a basic equation that you guys learned to solve earlier in the year. So B is then equal to 125 degrees. Right? For number 2, it says A and B are complementary. Well, you need to know what that means. And remember, complementary means add to 90 degrees. So these two angles add to 90 degrees. Well, here they don't explicitly give us a numerical value, but they give us an expression. So 4x, that's angle A. So let me write it out. Let me write it here. So angle A plus angle B, we know is equal to 90 because they're complementary. Well, angle A, we represent it with 4x. So 4x plus angle B is 2x plus 12. So 2x plus 12 is equal to 90. And now this is a solving, once again, an equation that we did a lot throughout the year. We combine our like terms, so we simplify. So 4x plus 2x is 6x. And now that there's nothing else that we can simplify, now we're undoing our PEMDAS. Remember, we're doing this in reverse. So I see that there's addition and I see that there's multiplying. So I get rid of addition by subtracting. So I subtract 12 from both sides. So 6x is equal to 78. And now I'm going to get rid of multiplying by division. So that means x is then equal to 13. So that is solving for x, but that's not what they asked us for. They said, what is the measure of each angle? So now we do need to plug it back in. So angle A we know was 4 times x. Well, angle A is then equal to 4 times 13, or the measure of angle A is equal to 52 degrees. And now we can solve for the other one by plugging it back in, or since we know that they're complementary, we could do 90 minus 52, but I'm just going to plug it back in just because. And this is a way that you can actually check your work. So now we have 2 times 13 plus 12. Well, 2 times 13 is 26, plus 12 is then going to give me 38 degrees. And then I can add these together, 38 plus 52, that's 90. If it didn't add to 90, that means I made a mistake with my solving for x. That's why it's good to plug it back in. All right, so for this one, we want to know what angle x, y, and z are equal to. So x, y, and z. We know that this angle here is 120. So we know that these two form a straight line, which means they have to add to 120. So 180. So 120 plus z is equal to 180. I subtract 120 from both sides. That means z is then equal to 60 degrees. So I know z is equal to 60 degrees. Once I know that, I can solve for x right away because I know that these two angles are formed by two lines intersecting or two pairs of opposite rays. So it means that they're vertical, and we know vertical angles are congruent. So x and z are the same. So if z is 60, that means x has to be 60 as well. We could have also solved it by seeing that these two form a linear pair, and we know that 180 minus 120 is going to give us 60. Either way, it doesn't matter. And then from here, now we can solve for y because we know that these three angles are going to add up to 180. So I can say x plus y plus 90 because that's what that box means is 180. Well, we just solved that x is 60. So 60 plus y plus 90 is equal to 180. Well, 60 plus 90 is 150. So y plus 150 is equal to 180. Subtract 150 from both sides. So y is then equal to 30. And there's a few different ways you could have solved that one as well. You didn't have to actually set it to 180 because you could have identified, well, if this angle is 90, and I know that all three of them add to 180, that means that the remaining two have to be 90 and complementary. But there's different ways you can go about solving it.